I have an equation in which the variable is in the exponent. My best chance at getting the variable out of the exponent is to take the logarithm. So if I take the log of both sides, I have the log of 4 to the x minus 3 is equal to the log of 7. Now I use natural log, but really you could have used common log if you wanted to. I don't suggest using log base 4 because it's not a log that's commonly found on calculators. If you're doing these expressions, I prefer either natural log or common log. The x minus 3 I can cycle in front. To isolate the x, first I will expand this term as x log 4 minus 3 log 4. I will move everything that doesn't involve an x over to the other side. So now x log 4 is equal to 3 log 4 plus log 7. And finally I will divide both sides by the log of 4. So x will be 3 log 4 plus log 7, all divided by the log of 4. Now, if you were allowed to use a calculator, this is the point at which you would calculate. But for this test, there won't be a calculator available. Having said that, I think that the answer should be somewhere between 4 and 5. And that's just looking at my original expression. 4 to the first power, 4, is too small. 4 to the second power, 16, is too large. So x minus 3 has to be between 1 and 2, so x has to be between 4 and 5. This problem. I think my best bet before I take the logarithm is to move everything over to one side. I have x squared e to the 2x minus e to the 2x is equal to 0. The reason why I'm tempted to do this is because I can pull out a common factor of e to the 2x, and that will be multiplied by x squared minus 1. The x squared minus 1 itself factors, so I have e to the 2x times x plus 1 times x minus 1. If I'm multiplying things together and getting 0, then at least one of the things has to equal 0. So either e to the 2x is 0, or x plus 1 is 0, that's basically x is a negative 1, or x minus 1 is 0, that would be x equals 1. But I should make sure that each of these makes sense by themselves, and in the original, I don't have a problem with the minus 1 or the plus 1. Plugging them in, they obviously work. It's the e to the 2x equals 0 which I don't like. If you recall, e to the x as a graph looked something like this. The key is that e to the x is never 0. It's always going to be positive. And e to the 2x would just be e to the x squared. So this answer, this apparent answer, is one that you're going to get rid of. I'll put a big X underneath that to show I don't want it. And to highlight the fact that I do like these two, I am going to circle them.